Okay, hi everyone. Thank you so much for joining. I'll quickly introduce our speaker. So Sarah Stone is joining us. Sarah is the executive director at the eScience Institute, which, if you don't know, is right down the street at UW. And I've been a huge fan of the eScience Institute for like 5 years. It's the reason my wife and I moved to Seattle. We did one of their programs called Neuro Academy, which had a transformative impact on my career. They taught us, how to do software engineering. Taught us basically software engineering best practices and how to apply those to science. And I think the eScience Institute has been innovating pedagogical approaches and approaches to scientific computing for many years. They have a lot of different programs going on. I'm super thrilled to hear from Sarah about all of these programs, including data science for social good programs, which of course aligns really well with our work here. So Sarah, prior to eScience, she was an assistant professor at Humboldt State. She's an oceanographer by training, which is, again, one of these special connections that Skylight has. Feels like the stars are aligning. So in that respect. So thank you so much for joining us. Super thrilled to have you here and excited to hear from you.
Well, thank you for the invitation, and thank you all. And those of you who are online, it's really a pleasure to be here. I think we're a reasonably small group, right? Are we seeing them?
Yeah, I think we're okay.
So if it's okay with you, like I do have a deck of slides, and it's really walking through kind of an overview of what the eScience Institute is doing. At a fairly high level, I've tried to focus in on examples that I thought might be particularly relevant to this group, not knowing in a whole lot of detail what you do, but kind of in the environmental space. But it's fine with me if people just want to interject questions. Honestly, I think that makes it more fun for all of us. So please don't hesitate to do that. Those folks online too, I guess they raise your hand or however it works in Google Meet, which I'm getting familiar with.
Yeah, feel free to.
Oh, I love the floating around.
We can do emojis, or feel free to just unmute and speak, or if you want to raise your hand, that's fine too.
Yeah, great. And thanks, Patrick, for inviting me and for the generous introduction to the eScience Institute. I was really pleased when we connected and Neuro Academy had really made a difference in your life, because we hear that quite a lot, that interactions with eScience kind of change people's trajectory, and particularly in terms of their career. And I think that's often folks who have, in the course of, have been in applied disciplinary space, but have gotten really interested in developing data science or AI tools in that disciplinary space. And they find that that's kind of where their passion is. And there really hasn't always been a space in academia, and arguably maybe still isn't in a lot of places, for people who kind of want to have a foot in both of those places. And I think it's still true in a lot of disciplines that they might not be seen, say, as a biologist if they're spending a lot of their time more in the methodology space, if they're publishing more in methods journals, if they're focused on software, because those have traditionally not been sort of artifacts that have been valued in advancement in sort of formal academic settings. I think that has changed a lot. It's changed a lot even in the 10 years that I've been with eScience. And it's fascinating to see how some disciplines have changed more quickly than others, and some disciplines have adopted really different practices. But that's kind of what the eScience Institute is all about. And I'll start by saying you might be thinking eScience, that's a strange name. And it actually goes to our history, which is we turned 15 this year. So the eScience Institute has actually been around for a long time in the sense of the data science AI world. And our name reflects that. So eScience was a term that was used for data science before data science became more popular. And we talk regularly about whether or not we should change our name to something else, because I always have to say the eScience Institute, the data science, the hub for data science. I always have to have some tagline that goes along with it. But we do have a fair amount of name recognition. So we go back and forth. And I guess after 15 years, maybe you just stick with it. Let's see. And so just to provide some institutional framing, so this is again around 15 years ago, there was this recognition. We had some really forward-thinking faculty and leaders on our campus, including our founder, Ed Lazowska, who really recognized that there was just going to be vast amounts of data across all fields. This wasn't going to be specific to one particular disciplinary space. And that really to stay a leader in research, that UW researchers needed to have access and understand how to use techniques and technologies in the data science and AI space, and that we really needed to figure out how to make them accessible to researchers coming from really as it says here, the broadest imaginable range of fields, knowing that for most disciplines, there wasn't any history of training students or the faculty themselves being trained in any of these methods, right? And for some disciplines, arguably disciplines like astronomy or even oceanography, that started happening longer ago, so it was getting integrated. But in many fields, if you look and think about like in social sciences, where it was really only through social media that suddenly they had big data, instead of having maybe 100 people surveyed or 1,000 people surveyed, they had enormous amounts of data and could really approach sort of core questions in their field in a wholly new and different way, but had no training in how to do that. And so that's what eScience has really always been about. It's less about, I would say, creating those cutting edge tools and technologies, and more about how can we help researchers, regardless of which discipline they're coming from, utilize those to accelerate and advance what they're doing and the research questions that they're interested in. I think one of the things that has helped us to really be successful and impactful on the campus is, which I've already said, like this broadest imaginable range of fields. And our logo is actually inspired by this. So this figure, this is the UW campus. Around 2014, we were selected by the Moore-Sloan Foundations to be one of 3 Moore-Sloan Data Science Environments. The Moore-Sloan Foundations recognized, kind of, as I was alluding to when I started, that there is a real need for data science and AI expertise on campuses, but that there wasn't really a natural home for that in terms of providing that as a resource to the campus community. And to make those positions prestigious. And I'll talk about that too, because that's been a real thrust of our institute. But those circles represent, for that initial group that got together and were key players in the proposal that went to the Moore-Sloan Foundation, those are all the circles and all the different parts of campus they came from. We're in the center there on the corner of 15th and Northeast Pacific. And we had we worked with kind of on the branding, and people kept suggesting all these logos. We had professionals working on it, and we ended up feeling like everything was so generic. And then we went back to this, and they would not allow us to have all those dots because that looks entirely too messy. But that is our inspiration, and I think for a university campus, and I imagine many of you probably all have varying degrees of experience on university campuses, but they can become very siloed. And it can be hard to get conversations to happen across disciplines. And the approach that we've taken at UW is that to really see data science as kind of a suite of tools and techniques that are needed regardless of which field you're in. You might need a different, that's going to look different for a student in computer science than a student, say, I'll just choose oceanography, right? Where we might have a focus on ocean modeling as our, the sort of visualization component of the work that the students are doing. But we weren't and haven't been interested in creating, say, a department of data science, or a college of data science. And you'll see that other campuses have taken a different approach. We don't know who's right? It's too early on. But the bet we've made is we've tried to do an integration of data science into the departments, and especially in terms of the curriculum. But we're able to have those kinds of conversations because we're not seen as CS coming in very heavy-handed and making changes for an entire campus. We are an institute that sits outside of that departmental structure, which means we can get people to come to the table and have conversations and really do something at a campus level. And so I don't know how much disciplinary neutrality matters in your context, but in our context, that's allowed us to do a lot of things I think would have been much harder to do if we were coming from a particular department. So as you can see here, so our executive committee is made up of people who come from very different backgrounds and different parts of campus. I won't belabor that except for to say we are really governed by thinking about what's needed, what the bottlenecks are, what are the questions people are asking, and we're getting feedback about that from people coming from a lot of different disciplinary spaces. We do have a beautiful physical space, and I emphasize this even though we've all gotten so used to being in the virtual space. We do really see the importance, and I don't know if you guys, how you feel about that here, of having people actually come in and overhear each other's conversations and talk to each other, especially in the space that we're working in, where we're trying to recognize what are the similarities that people across very different disciplines, what are the similarities and the challenges they're experiencing. And we have a number of different working groups that are oriented around that. So for example, we have a group that's interested in satellite image analysis, right? And so people across so many different disciplinary spaces use satellite image analysis, but they may have very similar challenges in terms of the image processing, right? And so they can come together, and things that might be developed in one field, because we can be so siloed, may be unknown to people in other fields. And so sitting in a shared space and overhearing somebody's conversation can actually be a way that people learn things and move forward. So we still have an emphasis on that, albeit I think we've all learned some things about how to do that in virtual spaces, but I do think I think we all feel a loss of some of those, you know, I guess water cooler conversations that can happen in an actual space. And I would encourage, I intentionally put this slide in here too, because we would love to, like, if it's interesting to you and you'd like to just have an opportunity to come and hang out with us, this is an open space. It's a former library space. And so we'd love to have you all, you know, maybe come and present what you're doing if that's of interest. We have a core team of now about 20 data scientists and software engineers who are part of our group. And they'd be really interested to hear about what you're doing, and you'd be welcome to, you know, do what I'm doing here, like come and just do, you know, kind of a meet and greet and get to know each other. In terms of the career paths, I mentioned this up front, so that, you know, when eScience started, faculty and non-faculty researchers who were really spending a lot of time in tool development weren't necessarily seen as core participants to their disciplinary space. And so we were very much, and continue to be very much, engaged with trying to support bringing in faculty who, again, have a, you know, foot in their disciplinary space and also more in the technical development. And we've always had much more of an emphasis on people. We see people as the sort of limited commodity here. I'm sure you guys do too, right? Computational infrastructure is no longer what limits us. What limits us, well, maybe lately, yeah, maybe lately. Okay, well, so maybe I shouldn't say that, but we, like, the people infrastructure, the intellectual infrastructure tends to be the limiting factor, or at least that's the focus we've taken. We do often have people come to us and say, like, how do we get on the cluster, and, you know, things like that. And that's not really, like, we help point people in the right direction. And we have a real emphasis in our group also in the cloud, and we do have to support some different types of cloud compute infrastructure. But in any case, we have a real emphasis on people and trying to create positions for people who were really working at, you may have heard them called pie-shaped people, so where they're deep in a disciplinary field and deep in a technical space. And so these are just a few of the data science faculty hires. So these are, you know, tenure track faculty that were hired in collaboration with eScience and with the provost. There was a big initiative now, again, about 10 years ago. And then more recently, there's a new data science minor at the University of Washington, and the provost has really been pushing to develop training and draw students from the arts and humanities into data science. And so we've had a number of faculty hires in the humanities and social sciences. Most recently, we have a new faculty member coming in gender and women's studies, who studies kind of the technological interface or kind of technological development in the context of gender roles, which she's coming on, I think, starting fall quarter, which started today, I learned as I was walking around the campus, and there were suddenly all those students you kind of forget in the summer that they're missing.
It was nice.
Yeah, and then you're like, oh gosh, there's everybody, people. Oh. And we also have affiliates, and actually I should mention here, like, not all of our affiliates our faculty members. We have affiliates who are outside of the university. So if it would be, interesting or meaningful for you to be affiliated with the eScience Institute, that just means you'll get more emails from me or other people on our team and learn more about the events. And we'd be happy to have you affiliated if that feels meaningful. Let's see. So this is our research team. So I mentioned we talked about the importance of building out data science and AI expertise on campus. And so we have those, we've helped to support a lot of the tenure track faculty positions. But in-house within the eScience Institute, we have a research team. And this is sort of an arbitrary designation, but means something kind of internally. But so we have a team of data scientists and research scientists. The real distinction here is the data scientists. These are full-time hires through the eScience Institute, so they spend all of their time with us, versus research scientists who are hired through other units on campus and spend some of their time supporting different eScience projects. I always like to put this up just again to emphasize, you can see that these folks, most of them are PhD level scientists, and they come from a variety of different fields. I imagine that's also true here, right? Where maybe you find value, is this true? I don't know. In bringing people who come from really different disciplinary backgrounds. All of these folks, so the way these positions are structured, we want them to feel prestigious within the academy. And you guys, again, you know what the academy is like, that sort of tenure track faculty are kind of the thing in the university landscape. These positions are not tenure track, they are research scientist positions. But all of these folks, they have half of their position is dedicated towards them continuing to be able to do their own independent research. So they continue to have their own research programs, and they aren't soft money positions, they're fully funded, but many of them do end up, writing and getting their own outside funding. And the other part of their position, the other sort of 50%, is supporting various eScience programs. And they're expected to work across various different disciplinary spaces, taking the expertise that they have and sharing those and helping researchers across disciplines. And I think these positions are really different than anything you see in most other universities. So this was a real hallmark of the Moore-Sloan Data Science Environments, and that we've been able to keep and support these positions in the Seattle economy, I think really says something for the success of these positions, because you know how hard it is to keep a data scientist or people with these skills in a job where frankly we can't pay probably what you guys make or what you can make in the market. And so that research independence is really a big piece here of I think why we're able to maintain this group. And we're currently we're hiring 2 more data scientists. That's why I was just telling Patrick this morning, we have one of our social science data scientist candidates on campus today. So we are building out and growing this team. We've also been involved in training programs, particularly for graduate students. Often these take the form of what used to be called IGERTs and are now called NSF NRT grants that support graduate student training. Some of these have been explicitly in the data science, on data science, like the initial IGERT, and many of these are in collaborations. For example, you guys might be particularly interested in the Future Rivers graduate training program. That one's just wrapping up, there's a number of graduate programs that we are written into proposals for currently that we're hoping will come through, and again, across a lot of different disciplinary spaces. We used to have fully funded postdocs. That was when we had the Moore-Sloan program. Right now we have a titling program, so postdocs who are at the University of Washington can apply to get the title UW Data Science Postdoctoral Fellow, and they become part of this very interdisciplinary postdoc community. Again, with the idea that they're sharing what they're doing, they're learning things from people in other disciplines, and using that to advance their own research. And we have supported over 100 postdocs in this space. I know you guys do postdocs. That might be an interesting thing to talk more about, if postdocs who are right? You have postdocs
What do we have? We have like postdoctoral fellows.
Yeah. If they might be, if it would be of interest or a good fit, like being part of our postdoc community. I know we have a shared postdoc program with the Allen Institute for Brain Science, and so their postdocs This is through the Shanahan Family Foundation Fellowship. Their postdocs are also part of our postdoc community. That just means they can come and join for lunches. They give chalk talks to each other. There's some career support. So that's something we could.
Ali just to talk, yeah.
Something we could talk about, or like maybe even if there's avenues to do something sort of explicitly for postdocs in the kind of AI environmental space, because we have a lot of our postdocs are coming in, particularly in the like geosciences. We have a real strong team, both on like a number of these folks, you may have seen that going through. A number of them are in geosciences, water resources, cryospheric kind of areas. And then we draw in a lot of students in that space as well.
Who do we have in AST who's actually the equivalent of a postdoc? You know?
No,
I don't think we have anyone in AST.
Not within ASC.
Yeah, it's partly because of our heritage and starting more at Vulcan and a little bit more with the private sector.
The incentive is different. There's a publication kind of, advancing science. It's artificial, but it's real in terms of, the publication side, advancing science side, and for us, the shipping product is something that actually gets used.
Right.
Yeah.
Yeah, well, it'd be interesting maybe to think about if they're like, I don't know if a postdoc, I get what you're saying, like, and also often postdocs are real kind of true research kinds of.
Well,
positions,
even on the
they
product
might be-
side, there is always, even from the most hardcore academics, the adoption phase in terms of getting the new product out there. But for us, the product, 99% of it is not that. It basically is a long tail of actually supporting actual users and stuff. And that, to me, there's a fundamental conflict with that in academia. I've never seen it work successfully in any organization.
Yeah.
So for me, that has to be discussed up front and resolved up front, not post facto. Right. So, yeah.
Yeah, that makes sense.
Yeah.
Well, anyway, that'd be interesting to talk to you more about. Yeah.
I mean, what we do have is certainly within climate modeling is a pretty active summer intern program, which is drawing people in which we've advertised through eScience.
Yeah.
We've had a couple of UW students who are part of that, although it's sort of not been so much through eScience as much as departments. So
We have found, and this is increasingly true at Skylight, there's academic labs who would like to get their research out in front of users to validate it and to see it sort of come to fruition, really. We had a conversation this morning with a lab and they developed some model, and we're I think, to me, that's also a good way of there's a feedback loop, because obviously, like, if you're writing papers, publishing those, that's it. And then there's no like, well, how am I going to actually make it better? And ML obviously improves from feedback, literal feedback. And so I think researchers like that because they can get, especially at scale, they can get, a feedback signal into their model and then make it way better. And so I think there's a really healthy kind of there can be very synergistic relationships with the whole like publishing and. Yeah.
I think so too. I think, it depends on what the researcher's objectives. I think there is a lot of research that really,
it might
it's like,
fail.
I did this new thing. I don't really care what happens. I'm going to go on to my next thing.
But if you vet that up front, I think you can be pretty successful. You know what I mean? When you just are upfront about that and they understand what their incentives are, or their objectives are, I think it can work out pretty well.
Yeah, I imagine you run into like we run this data science for social good program, which we're not going for commercialization necessarily, or that's usually not the thrust of those projects, but we sort of run into a similar problem in that we're really trying to do very applied work, and faculty aren't necessarily like there are different products that they're looking for and different kinds of measures of impact. And so we can get into a space of tension there too, I would say. Yeah.
Well, tension are just like, there's not enough resources to cover, you know what I mean? It's like, it's not hostile that way. It's just more.
Oh, no, I just mean, a friction between like where you put your resources.
Where you put your resources, the prioritization.
It's really like the currencies are completely orthogonal. Like in one case it's papers, and another it's currency, like actual currency. But I still think, particularly for ML, because of the benefits from that feedback loop, like in terms of a supervisory signal or an RL signal or something like that, it's especially salient, as opposed to a conventional statistical model that doesn't require or doesn't benefit from a teaching signal.
Yeah. So I'll just mention briefly, I know that this part, I'll mention both the formal and informal training. Informal training really gets into what we do as an institute. But I'll just mention, just in case you're curious, like what is the University of Washington done in terms of data science and AI education in a more formalized capacity? Of course, there's many, many courses that exist across many different departments. But as the role that the eScience Institute has played, and again, this gets back to kind of being this neutral entity, is that we got together people from 15 plus different departments and created a framework for what that group agreed on were the key components of a data science education. And this started at the graduate level, and you'll see that that's the advanced data science option. There's an advanced version of the graduate option and a standard version. The advanced data science option is essentially all the highest level courses in those different categories. And the categories would be all the things you'd expect for programming, statistics, machine learning, data visualization. I'm forgetting some, I'm forgetting some of the other ones. Those are the four main ones. There's a data ethics requirement. But they're the highest level courses are the advanced, and then the standard option has a lot more flexibility for departments to sub in classes that are a good fit. Like I think I mentioned earlier, for the oceanography department, they might sub in their standard data science option. In fact, they do like an ocean modeling class for the data visualization requirement, just to give you an example. So that students are actually taking the classes that are most meaningful for their disciplinary space and are going to prepare them for the world they're going into out of their major or out of their graduate degree. And so the option then sits in the home department. So I would still get a degree and, I would still get, say, a PhD in oceanography, but I would have a data science option, and that would be on my transcript. And so that's how all of the options work. The really nice thing about the options is, again, they have that flexibility for most of them for the department to put the appropriate classes in within this framework. So you can't just throw anything in there. It has to have the level of rigor that would be expected for a data science curriculum. But they own it. So they're not losing students to some department of data science. Suddenly they're still attracting their same students, but their students are able to pick up those skills within the context of their primary area of research or study. The data science, so we did that at the undergraduate level too. What we discovered at the undergraduate level is undergraduate majors are really impacted. It's hard to add any classes. And so the data science option worked well in methods departments. So it was easy for a CS student to add a data science option because they already had a lot of the same classes, easy in applied math, statistics, harder in other places, although there are departments like atmospheric sciences has one that have managed to do it at the undergraduate level. But that really indicated to us that we needed to have a minor that would be available to all students. And that minor is really structured around thinking about providing students who many of whom aren't going to become data scientists necessarily, but they're going to be in data adjacent roles. And so it's going to be helpful to them to understand the language and we more and more see students going into roles in our local, tech environment where, again, they're kind of data adjacent. They're being the intermediary between teams of software engineers maybe and the other parts of the company to help explain what's going on. And so the training is really more in that space in the minor. Let's see. So in terms of what eScience does, because as I mentioned, we're not a department, so we can help to provide some of these conversations and make things happen in the formal curriculum. But most of what we're focused on is in the informal education space. And most of us can't go back and be a freshman in college and start from scratch and learn all the things maybe we should have learned to be in our job where we are now, right? And so we're trying to to be able to fill those gaps. And so the team of folks that I showed you previously of data scientists all provide office hours, which are available to the campus community for free. And they all have different areas of expertise. This is just an example, Brenna, and it shows all the different areas of expertise she has. And those office hours are a really nice way for us on campus just to, people have a one-off question, we can direct them into office hours. As an institute, I spend a lot of time thinking we want to be able to help everyone who comes to us because that's part of our role in a service capacity to the university. And office hours is a really nice way just to channel inquiries that come in. When we start getting a lot of inquiries from the same person over and over again, then sometimes that moves into maybe somebody's going to get written in on a grant or, get involved. But, at some point we have to say, we can't keep doing this in this capacity without having some more formal arrangement. One of the things we can point to is we have a data science incubator. And so this is an opportunity for a researcher to work one-on-one with a data scientist, and it lasts for a quarter. And the expectation is that they're sort of spending about 2 days a week really working. We used to say shoulder to shoulder in Zoom, it was Zoom to Zoom, or, and all of our programs are structured around people don't throw data over the fence and we do magic and throw it back. It's really about teaching people to fish, forgive the analogy, but teaching, really trying to create a shared learning environment that then ideally, and in some cases really happens, goes back and changes the way an entire lab might be doing their work. It might change their entire workflow. We worked with folks in radiology, for example, and really made their whole workflow reproducible and something that or if you think of it in the software space, each new graduate student isn't coming in and writing the software again. I'm sure we all dealt with that, right? Where you come into a lab and there's some ancestral piece of software that was not well documented, and essentially each new graduate student rewrites that code, right? So the incubator is a great place to help to change how both an individual is working and ideally how their broader lab or even maybe a discipline, if they're working in a space where they are, have a kind of a tool that is used by a large fraction of the community. And so this is something we run every winter quarter. We've done a lot of projects in the incubator. This is one of our most kind of successful programs, and I'll just show you a few of these because I think I tried to pull some, to show the breadth. So I thought the first one might be of particular interest to you guys. That was a really fun project. But you can see we get projects that come from, say, political science, medicine. We've done a lot of projects in the geosciences, biological sciences, and civil and environmental engineering. That's just a few examples there. It might be interesting to think about how, if there were projects that might fit well into that 10-week period, if maybe there's even a way for us to share and doing something together. I don't know, it wouldn't be maybe a traditional incubator. Usually most of the incubatees are graduate students or postdocs. Sometimes we have faculty on sabbatical who will work with us, but that could be an interesting structure. Or maybe if a student is working in a space that's overlapping with some areas of interest, maybe it could be a co-mentorship that maybe we're providing some piece of the mentorship and somebody on your team might be involved to come and bring a piece, or, I don't know quite what that could look like, but.
We have some precedent for this. And I think that could be, we should follow up on that just because the Global Innovation Exchange, at UW, we've been there from before they started. We haven't always funded a cohort every single year or thing, but, and they're still kind of, to be honest, they're still somewhat nascent, but we have had that kind of structure where there's collaboration, maybe a little bit more than 10 weeks, but there is that, period of time, a term kind of limit. And then, you're looking at your deer fear things, that's almost precisely the type of, I'll call it output. We want to, that's all, I should probably look into that, but that's almost, exactly the kind of thing that we want to develop together. So sounds fun.
Okay.
Yeah.
Cool. Some of the other things we do that I thought, you might be interested in. We have a university seminar series, who doesn't, but this brings together, kind of thought leading people across engineering, arts, humanities, and sciences, and data science and AI. Our first seminar next week will be replaying the recording of our Data Science for Social Good project talks. That program runs 10 weeks in the summer and they give final presentations in August, but we always like to show those again because they reach a totally different audience. And so that'll be the first one. But again, that would also be a great place. If you're trying to build collaborations or contacts on campus, please just reach out if you'd like to give a talk or you'd like to have a team of people give a talk. What can be really fun too is to have somebody come in, do a shared talk where one person gives more of the domain context and of the problem, and then the other person, or it can be the same person, but I always enjoy it when it's kind of a tag team, comes in and dives into the method space. This seminar series does bring people from very different disciplines, and so, but they're all interested in the methodology. So that's kind of like, we always encourage people to actually spend more time in the methodology than they might in another talk. And then we do all kinds of workshops. We try and be responsive to what's going on in the campus community. We always run software carpentry. I don't know if you know about software carpentry. They're an international nonprofit organization, and they have some really nice, well-honed intro programming curriculum. And even if you're just like, if you're working with somebody or you're moving into a new space, it's not all at the introductory level, but a lot of the courses that we teach are in R and Python, and sort of introductory to working in the command line, but they have much more sophisticated pieces, and they do a really good job of it. They focus very much on pedagogy. They're one of the first groups to actually think of how you teach hands-on keyboards programming effectively. And so we follow their curriculum. Have you done anything like that?
Yeah. I mean, I became an instructor through their like instructor series or whatever, and I thought their pedagogy was super state of the art. I mean, I don't know much about pedagogy, but my wife does, and they're like pretty serious about doing scientific best practices and especially it's hard to teach software. And if you're like mentoring or whatever, I mean, I did it during my PhD, but even as in professional life, it's helpful for training and helping like junior engineers, especially if like just simple things, or like turns out that if you ask a question to someone and then don't wait more than like 10 seconds, they're probably not going to say anything regardless of whether or not they have a question. So they had a bunch of good tidbits like that.
Yeah, and if any of you are interested, like, so software carpentry, it's a totally volunteer community in terms of the instructors, and they have like 1,000+ people worldwide. We run the carpentries programs every quarter. So even if you just wanted to see what it was about, we always need like helpers, and you guys, I'm sure would all be very qualified to teach. You don't have to be an instructor to just come in and even like teach part of it or help. Or if you're interested in the instructor training, we offer that.
It is a serious commitment if you teach a class, right? It's like 3 weeks.
Oh, no,
like
no,
that,
it's
right? Not like that?
no,
I thought it was a big commitment.
no, the classes are, we do it as 4 half days.
Oh, okay.
It's usually 2 full, or most people do it as 2 full days. We found retention and knowledge acquisition is much better on 4 half days.
Okay.
And we often have people come in and help and just do 2 hours.
Okay.
Like, and maybe you'll teach like the, Python piece or something.
We should do software coverage for Congress. I lived in DC.
Yeah.
Need some of that.
Yeah,
Science carpentry.
we've actually been working on building a carpentry style curriculum for people in the public sector, because there's such a huge need in government and nonprofits for people with data skills, and often there's not a lot of good training available. So we've been trying to build out something using examples that are more like the data sets that they encounter in public data. So one of the programs that Patrick mentioned, and that we now offer almost as a service to communities, are Hack Weeks. And I'm sure you've all heard of hackathons. Hack Weeks are a bit different, and Patrick can talk about this. And the first one was focused in astronomy, but we've done them in geospatial sciences. There's a long-running neuroscience, NeuroHackademy. And the idea is not to create a competitive environment, but actually to create an immersive and inclusive environment where you're bringing together researchers, particularly or generally in a disciplinary space like neuroinformatics. We've done it with NASA around a satellite mission. So they're trying to build the tools that are going to go along with the satellite mission and the community, honestly, because they put those satellites up and they need people to actually use the data, because like it costs a huge amount of money. And it was, they decided to do it for a reason. So we must have thought it was useful. So we've worked with them on a number of satellite missions, particularly some that have looked at the cryosphere. So ISAT-2, we've done ISAT-2 Hack Weeks now for 3 years. But really it tends to be about a week-long event, and it's a mix of trainings and tutorials, kind of peer-to-peer learning, and then hacking on particular projects, sometimes that arise organically out of the group that's there. People do pitches And then those are the projects that teams work on. I think on the satellite mission, sometimes it's a little more constrained, like they have particular areas that they're focused on, or the data set is more constrained. And so because we had these developed across a number of different disciplinary areas, we started getting all these inquiries about how do you run a hack week, and can you run a hack week for us? So there is we have an online hack week toolkit. We're not trying to keep anything secret, but people will still like, well, I don't just want the toolkit. I want, like, can you guys just come and do this for us? And so it is something that we provide, but we also, if you get on our mailing list, you'll see that there's a number of these that run every year. Ocean Hack Week might be particularly interested to this group. I know a lot of you are working in the ocean space. We have a GeoSmart Hack Week coming up that's more geoscience focused, particularly on water resource, water cycle stuff. I would say throughout, like, a real hallmark of the work that we do is that we really approach the projects that we take on in an ethical and responsible manner. So meaning that when we're working on a project, we're making sure that we have domain expertise on any data sets that we work on, and an understanding of data ownership, and are thinking very reflexively about what the potential impact is of the work that we're doing. And this is actually just showing a group of our Data Science for Social Good fellows a couple years ago, and you can see they're working through, this is a 2x2 where it says stake and power, and they're asked to identify for the project they're working on who are all the stakeholders, from those that are most obvious that you're collaborating with, maybe very directly, to those very far afield who might be affected by this work. And where are they on this, like, how much power do they have and how much stake do they have? And then once you've done that, for where things sort of are at the beginning of the project, if you're successful, how does any of that change? And really thinking about that very deeply. And I think the students come out of that experience, and we hear from them that that's a skill they just don't learn anywhere else. And a lot of these students are coming up, well, they come up through a lot of different disciplines, but certainly those who come up more through engineering disciplines, this is not something they've ever had training in. And if you're working in the social impact space, if you're working with data about people, I would argue you really need to be thinking in this way about anything that you're doing. And so, yeah, so our Data Science for Social Good program, this program runs during the summer for 10 weeks. And we bring student fellows from universities across the country. So these aren't just UW students. We are open to any students at universities in the United States. And we've been running this program since 2015. This is, I'll just unabashedly say, my favorite program. And it's just a really wonderful opportunity to get students engaged in doing really important, impactful work. And they are the students, we work very hard to get students who that's really what they're excited about. So these aren't just students who are wanting to use the newest ML tool. They're students who really, they might want to do that, but they want to do something that is going to impact their community or make a change in the world. And so this is something Patrick and I have talked about potentially taking on a project that might fit into this program. And so we do a call for proposals, both internal to the UW, but also to outside organizations. And that call for proposals is usually around January of each year, but we're happy to work with partners to actually scope a project and kind of sort of in advance of that call for proposals. We're interested in getting high quality projects and proposals that are coming into that program. The student fellows, as I mentioned, they come from universities across the country. Most of them are graduate students. Typically, historically, they've been about 25% undergraduates, and they're very disciplinarily diverse. And I think what you get in interacting is students who really are approaching the problem from a variety of different angles. And we frequently have project leads, so the people who submit the project say that the students pushed into a direction that they really didn't have any awareness of before, either in terms of the skills that they were able to apply or just in the way that they were thinking about it. A lot of the students really bring more of an ethical and equitable framing to the projects than sometimes the leads have really considered, and they've appreciated that component. We have done a lot of leadership in this space. We have a white paper that's really a roadmap for other organizations that want to build out data science for social good programs. We do that. Again, like we get hundreds of student applicants, and like who wants to say no to a student that wants to do something meaningful with data? So I'm just hoping other people will build out similar programs so that we don't have to say no to as many people. And we run a conference. We ran a conference last year, and we're doing a special session at the Academic Data Science Alliance conference, focused on really lifting up this work that students are doing in this space. I think I need to go faster, so I'm going to go. So these are just some examples of the SSG projects. I put in the top two are ones that we did this past year. I thought those might be particularly interesting to this group. The first was focused on trying to understand the role of groundwater in the Colorado River Basin, which is really understudied. Most of the work that's being done to understand dynamics in that basin is looking at like lake levels declining and like the bath ring, and groundwater is not very well understood, but the GRACE satellite data can provide a nice measure of, combined with some other data sources of groundwater and how groundwater is changing. And groundwater is what we rely on, I'm sure all of you know, like tremendously for, our existence. We also did a project on heating pumps in Alaska that was looking at the viability of getting people to use heat pumps in various parts of Alaska towards their effort of decarbonization. Let's see. I think I'm going to just jump through some of these because I have some stuff I want to get to at the end. But yeah, we work with a lot of partners. This is the part I wanted to make sure to get to talk about these two things. So Patrick was able to join us. So we have a new initiative on the University of Washington campus called AI at UW. And we've had two big events last year and then this year. Let me talk through those. And then, so this is, as you can see, across college and school initiative on campus. And the idea is to really lift up AI activities that are going on all across campus and make us aware of each other. We found that even so these are sort of 10 major AI initiatives on our campus, many of which these are funded initiatives, many funded by NSF, but a variety of other funders as well. And they all gave, in the initial event that we did last year, they all gave, lightning talks. And many of these centers had no idea of the other centers. When you're on a campus as big as UW, there can be a lot going on. And so even just surfacing what's happening on campus and helping the people realize that this isn't just happening in the engineering space, that there's a lot of applied work going on across very different disciplinary spaces. And so, yeah, the first event, we brought together 300 people. It was really trying to highlight the work that was being done. There was an AI education working group that is putting together a proposal for what AI education specifically should look like on campus. And then just this past May, this is what Patrick joined us, we had this matchmaking session where we had researchers give a lightning talk about their research, and we had people more from applied domain spaces and then from methodological or theoretical backgrounds. And then they could write proposals. And so we just made we have 4 funded seed awards that are coming out of that. And we'd love to think about how we might collaborate on, I don't know what that maybe could look like, if there's, again, particular areas that you might be interested in. What we're really trying to do is create those connections between people who are focused more on the methods and on the application and help them find each other. Because we frequently hear from people on the method side that, oh, like I developed this really cool tool and I need somebody to try it out, right? And, we're trying to help people work more closely together and find each other.
My recollection of that event, and correct me if this is wrong, but it was massively weighted towards folks who were looking for help on AI. So like they had an idea that required AI, and it was super lopsided towards those folks. And then there was like a handful of people who actually had technical AI expertise.
And that was with work, I will say too, to try and have as many as possible who got the expertise. I think probably what you experienced too is there's a shortage of the people who
Right,
have
that's,
the,
So,
Yeah.
okay.
But we got a good number of proposals and high quality proposals that came in. So I think that is true, that there's more people looking for help than there are people who have the bandwidth to help. And maybe that's something like, maybe that's something that we could figure out, like.
Yeah, no, I mean, it's tricky. For
Matching.
sure.
Or if I guess if there's projects that are related to work you guys are already doing, maybe that's expertise people in your group might be willing to provide to projects, or that's something we could think about or talk about. Great. The last thing I wanted to mention was we were about a year ago, we received support from Schmidt Futures to build out University of Washington Scientific Software Engineering Center. And the goal here is to really bring on professional grade software engineers to be producing scientific software. So something you guys probably have a lot of familiarity with, but is really largely lacking in the academic sphere. And while we've had teams of data scientists, some of whom have expertise in software engineering and certainly have helped to do education and training in, around software engineering best practices. This is the first real team of software and sort of exclusively software engineering focused people that we've had within eScience and within the university landscape to create this kind of center. So these are some of the folks we're still hiring onto this team. And the idea is that this will be a campus-wide resource for both the University of Washington. We're also currently supporting Schmidt Futures researchers. That's part of the deal with them providing the funding. And I think we're interested in how to scale this and maybe support, both more projects within the University of Washington, but also outside of that. As I talked about earlier, this is really lacking in academia, where we often have graduate students who are writing code, and that's not sustainable or reproducible. Let's see.
Happens all the time, though.
Yep.
What?
Yep. Let's see. I think I think one of the other things to emphasize here too is, while you may know and be familiar with software engineers in academic settings, they're often kind of a one-off, maybe in a department or in a lab. There's a lack of community, and that's, community can be a really important part of how software develops, and engineers are used to working together. So part of the idea here is to create this stable home and structure so that even if engineers are working on particular projects, they have a known, stable career path. We tried to get good salaries as high as we could get them within our structure. And they have a team of people that they're working with. And there's never a single person just working on a project. They work in teams, and they have the resources of the full team. And these are usually 6 to 8 month or 9 month engagements. These are a few of the projects. Again, I tried to pick out ones I thought you guys would be particularly interested in. The top project is a collaboration with Conservation X, where they're developing a platform that enables the researchers to rapidly create genetic tests for pathogens, pests, or species they encounter in the field, to rapidly be able to do that. NoisePi is looking at earthquake detection from a lot of background noise from sensors that are on the seafloor and other kinds of settings, a vast array of sensors. And then EcoPipe is looking at ocean acoustics. We've done a lot of stuff in the ocean acoustic space, often around marine mammal, trying to track and understand where marine mammals are, but also looking at other critters in the ocean that you can get backscatter off of. So again, I think there could be potentially some interesting collaboration opportunities there. Our head of engineering is Vani Mandava. She's a 25-year Microsoft veteran, so we have some real strength on our team. And this is my one last thing, in case this happened to be of interest. We will be partners on an NSF AI Astronomy Institute proposal. I don't know if that's way out in left field for anything you guys are doing, but if that, I just wanted to bring it up because we'll be writing that proposal going into the fall. And this is one of those big NSF AI institutes that get funded on the order of $10 to $12 million. And so that or even if it's not this group, if there are other groups that you think might be interested, that could be a great thing to talk about. Okay, and I think that really is it.
Great, thank you.